So, from a SIP perspective, how is a message prepared or marked for secure transport over TLS? Have a look at this invite and see if you can find the clue. Then go ahead and press play when you're ready. The clue for marking a request to be transported over TLS is, of course, the request URI scheme. As we can see, it's not sipdave@example.com, but sipsdave@example.com. With SIP-S in the request URI, the sending user agent demands that all hops along the message path, right up until the destination domain server, must be encrypted. Accordingly, TLS is used between the sending user agent client and proxy 1, and between proxy 1 and the destination domain server. Beyond that, well, it's up to the domain server to decide whether to send securely or not. So, another golden rule: if a routing address has the SIP-S scheme, it must be delivered over secure TLS all the way to the domain of that entity. Take a look at this one. What do you think should happen if the request URI has a normal SIP scheme, but one or more of the root headers has a SIP-S scheme? Have a think and press play when you're ready. A secure SIP-S scheme in the root header means the request should be routed securely just over that particular hop. For example, receiving an invite and deciding a feature from an external server should be applied, one outside the safety of the home network, the proxy adds root headers with scheme SIP-S. Because of the SIP-S in the first root header, the request is routed securely with TLS over that hop to the feature server. The feature server then, stripping off its own root address and finding another with a secure SIP scheme, knows it too must route the invite back over secure TLS. What happens after that? Well, it's up to the proxying server. The transport type over the next downstream hop hasn't been predetermined. Security in SIP is actually delivered on a hop-by-hop basis across one single hop at a time. Some hops may be secured, others might not be. It's important to remember that even if a message starts in normal unsecured SIP, it could still change between secure SIP and unsecure SIP en route. But security comes at a price. TLS requires a greater overhead compared to TCP or UDP. TLS needs a handshake exchange of certificates and keys just to set up the secure connection, both things that take time. But the greater security offered by TLS is well worth the overhead, especially when communicating between trusted domains over an untrusted network. Neither UDP nor TCP offer any form of security at all. So it's best practice to send messages between trusted domains but over untrusted networks using secure TLS, despite the overheads. Many networks these days mitigate the overhead by doing two things: by using dedicated hardware that accelerates TLS negotiation and the TLS encryption, and also by maintaining an always-on TLS connection with partner services, setting up ahead of time that handshake, negating the need to set it up again with every new session. Messages sent inside a secure network are not typically sent over TLS. After all, the network's protected from those outsiders with malicious intent behind the enterprise firewall. Now, any SIP address could be set with a SIP-S scheme. The request URIs, the root headers, and even the contact, the from, and the to headers. So, if Dave's published address of record uses scheme SIP-S, well, when Alice calls Dave, the request URI should also contain scheme SIP-S, causing the request to be encrypted over each hop all the way to Dave's home domain server, just as he requested. In summary then, SIP messages can be sent securely using TLS, that's Transport Layer Security. Messages are encrypted by the upstream entity using the downstream entity's public key and deciphered by the downstream entity using the downstream entity's private key. Encrypted messages can only be deciphered with the downstream entity's private key, something which is never shared. Public keys, on the other hand, are shared after exchange of certificates that certify identity. Messages are marked for secure transport with the SIP scheme in the routing headers. SIP in the request URI denotes the requests must be transported securely over every hop between the sender and the callee's home domain server. SIP in a route header, on the other hand, denotes the request should be transported securely just over that hop. Remember, TLS needs additional overhead for certificate and public key exchange, and then for the encryption and deciphering of messages. The overhead can be mitigated, though, through hardware acceleration and always-on TLS connections.